And we're looking at sustainable, safe and secure supply chains. So we're looking at product characteristics and standardizing products. We're looking at the risk mitigation. We're looking at the security aspects of it. Corridors, hubs and synchromodality. I mentioned this TEN-T, this Trans-European network. We're looking at huge amounts of data and where they're moving and trying to consolidate them in the right sort of, on the right connections, the right roads. It's fundamental that this system is dependent on information technology and the systems to support it. We're talking about cloud computing, we're talking about big data analytics. There's a huge amount of data that's going to have to be processed here because all the products will be tracked and traced. They'll be, as I say, they'll be safe and secure, so we know exactly where things are. And that's what the systems are going to have to do. Urban logistics, we're looking at different ways of trying to get goods into the city in the most environmentally efficient way, possibly using urban consolidation centres. And in fact, these urban consolidation centres could even be used for 3D printing, so you get local delivery of goods if it's too expensive. And then the coordination and collaboration, so making sure that there's transport planning, system planning to make sure it fits in with all these other themes within the ALICE roadmap. This is an example of a study in France where the top 100 suppliers, there's 100 of the top suppliers and going to 2 of the top retailers in France. And this is what it looked like when they mapped out the flows. But using the physical internet with the set network of hubs, you can reduce those flows down to that. And if you put that onto a road network, you can see the sort of flows that take place. And this is why Europe are looking at these trans-European networks to look at what sort of volumes might be on these roads so they can adapt the roads to cope with the volume that's required. So you can see how could be a dramatic change, and it's said here that there is between a 4% and a 26% cost saving by moving from that area to that area. So there's a cost saving as well, but about 3 times better in terms of greenhouse gas emissions by using road-to-rail modal transfer, multi-mode. Because the more volume you have going on a particular line, then you have the opportunity of using rail perhaps. Now, I mentioned about containers, and we're looking at modular containers in the physical internet. We have the 40-foot container. It did change the world dramatically, the way it was moved, we can move goods around now. That 40-foot container and the 20-foot container as well, we can really create much smaller levels of modules. And the whole point about the main innovation is this Pi container, this physical internet container. And we've identified through the Modular program, which you saw on the video, 11 different sizes of container. And they would be stackable on top of each other and fit. You'll never guess in Modular there was GKN was one of the consortium members. So these modules can all be stackable and put together into nice, neat profiles. And although with the product within these containers, it's been estimated there might be 10% less efficient in terms of space, there'll be more than 10% improvement in space on the back of a lorry. Now these containers are smart, so they are tagged with RFID and we know everything about them. So we know the condition of the product and where it is and where it's been and where it's going. Everything you want to know about the product is on those tags. These products are environmentally sustainable. They are stackable, as you can see. You can seal them. You can condense them down as well when they're not being used. So there's a whole range of different things. So it's optimizing the space with open networks, and you get less network complexity that way as well. Just going back, we've mentioned here the standard logistics service protocols. We need some form of standardization of all these different processes and systems and protocols. And we can do that by the standard logistics service, open logistics interconnection model. And you can see the sort of layers based on the logistics web layer, which is the characteristics of the product and the geographical characteristics, the encapsulation layer, in other words, what module, which module is being used, how many of these modules are going to be shipped, where they're going to, and the handling characteristics, what mode of transport and so on, moving back up, all being tracked and traced and visible. The Logistics centres are going to be radically designed. The hubs are going to be almost autonomous. So because of these standardized module containers, you'll be able to move things around very simply, very quickly, very easily. And there are different types of hubs depending on the way the cross-docking, the type of cross-docking that occurs. And you'll go through this relay system. There's going to be new business models. The crucial thing here, it's not going to be the existing players that will start off the physical internet. It's going to be the new players. We already heard about Google and what they're doing. Amazon, eBay, Apple will be the leaders in the market, which the others will then follow. So we're going to need real support from the academic community, from the government, from all the different research organisations to make this happen. There's also infrastructure changes. There's an example here of food tubes. In this country, we've got Mole Solutions. They've won a Technology Strategy Board grant to build tubes under Cambridgeshire, I think it's Alconbury, to look at moving food around through tubes. Or there's a cargo cap in the US as well, little modules that go under the ground delivering product. Again, autonomous. And again, because systems are so important, we can see how the computers have progressed over the years, and we're looking now at sort of optical and quantum computing, DNA computing even. We need to change, or the computers will change over the years and will become faster and much more able to handle the sort of data required for the physical internet. As I say, we're looking to 2050 here. And in order to do that, we need collaboration. So companies will need to work together, and these are the various factors involved that we need to work at. It's going to need a mental shift in the way people work. We're not going to compete in logistics. You're going to compete on the shelf. That's what a Nestle UB not on logistics. And that is a very good way of looking at it, because, as I said before, we are not going to be sustainable if we continue the way we are. So that's the conclusion. We're going to need academia and industry and governments across localities, countries and continents. It's going to need a huge effort from everybody to achieve this physical internet. It's not going to happen overnight. It's not going to be a big bang. It's going to be progressive, and it will achieve by 2050. That's the aim. So is this all pie in the sky? That's some source of information if you want it. And thank you, that's the end. I'm 15 minutes early. Any questions? Yes?
Is there any plans to do like a pilot project? It could be like London. Say, why don't you try it out in London or somewhere else before you really go scale it?
In the CO3 project, there were a number of pilot projects of collaboration going on, horizontal collaboration. Vertical collaboration is easy. Horizontal collaboration is much more difficult. There's lots of examples of horizontal collaboration, lots of pilot studies are going on, and there is a follow-on project called Next Trust, in which there's a huge number of companies involved looking to pilot collaborative collaboration and moving goods around. Now, the thing is, the physical internet isn't just the collaboration. It's the network of hubs, and it's the way the 3PLs will work together as much as the shippers, because that's the crucial thing, is getting the 3PLs to move the goods.
But I just thought that maybe you need some kind of political decision, and particularly in London, where you have a lot of traffic problems. Like political, you say, hey, we want the physical internet to be here. We want it to be like a non-branded movement of cargo into the city centre by 2020 or whatever.
I mean, when you're talking about urban or city logistics, like London, they've just opened the Hackney Consolidation Centre. There's consolidation centres at Heathrow. So there are examples of consolidation centres. And with London, there's going to need to be more of them because it's such a huge city. But these consolidation centres need to be cost effective And that's one of the big problems currently. It's always needed research to support these in the first instance, to give grants to make sure they work. But if we come across 3D printing, whereby these consolidation centres could produce goods for the city, so if they order goods, they could print them, there's another revenue earning stream that's possible for them.